Good morning, students. Today we are going to discuss a method for variation of parameter, which is a method for particular integral in case of general solution of higher order differential equations. This method is divided into two parts. The first part is what to do when we have second order differential equation, and second part is what to do when we have third order differential equation. This method is general method to find particular integral. Previously we have seen direct method. We have also seen method of undetermined coefficients, and today we are going to consider the last method for finding particular integral. So let us begin this technique. As usual, I am considering for simplicity second order differential equation. Y double dash plus C1y dash plus C2y equal to Rx. Rx is a random function of variable x. C1 and C2 are arbitrary constants. Y dash, Y double dash are first and second order derivatives of y with respect to x. This is our general format of higher order differential equation. This method is useful in case of variable parameters or variable coefficients also. That will be our next part. Now, if we define operator d by dx as capital D, then nth order derivative is d raised to n upon dx raised to n as capital D raised to n. Defining this operator will give us d square y plus c1 times dy plus c2y equal to Rx. Considering this into operator form will give us f of dy equal to r of x. Now, taking this into operator form, my equation will be f of dy equal to r of x. And then, as I told you earlier also, we have seen already direct method of undetermined coefficients for finding particular integral. Students, you should go for all these videos first before starting this variation of parameter, as this is general method which is applicable if this direct method and method of undetermined coefficient is not fitting to the particular integral. Okay. So let us start the first case of variation of parameter. I will discuss this method directly with help of examples. I will take one example and it will make clear that how to apply this technique. This technique is also known as method of Wronski's. In the solution, you will see why it is known as method of Wronski. Okay, so my given equation is y double dash plus y equal to sine of x, and I want to find general solution. So the first step is f of dy equal to r of x. Considering it into operator form, it gives us d square plus 1y equal to sine x. Taking f of d equal to 0 will give me d square plus 1 equal to 0. And this gives me two complex roots, 0 plus or minus I. It simply means that alpha is 0 and beta is 1. Now, considering real part 0, imaginary part 1, for third case of complex non-repeated complementary function, I will get CF as C1 cos x plus C2 sin x. Here, actually, the solution is e raised to alpha x into C1 cos beta x plus C2 sin beta x. Alpha equal to 0, beta equal to 1. Now, this is the technique which is known as method for variation of parameters. This technique is almost similar to undetermined coefficient when it comes to framing the value of yt first. In undetermined coefficient, we are framing the value of yt first and then we are solving those equations for a, b, c or d. Here, again I am framing my value of yt first, but The change is here I'm taking yc as yp. You can see here what is value of yc. It is c1 cos x plus c2 sin x. I'm considering yc as yp, but in place of c1 and c2, I'm taking arbitrary functions u of x and v of x. Rest of the method is to identify u and v. To identify u and v, we have three steps to follow. The first step is to consider y1 and y2 as cos x and sin x. Second step is to find w, w1 and w2. These are the Wronskians. And third step is to consider values of u and v with help of this integration. So let us go through this method. If I write c1 cos x plus c2 sin x as yc, then yp is ux cos x plus vx sin x. Now, considering y1 as cos x, y2 as sin x, my Wronskian w, this is nothing but a value w for y1 and y2 to check whether they are linearly independent or not. We have used this thing to verify whether the vectors are linearly independent or not. So I am taking y1, y1 dash, derivative of y1, y2, y2 dash, derivative of y2. Whenever I will write w1, I will replace column of y1 with 0. Whenever I will write w2, I will replace column of y2 with 0. This will give me w as y1 means cos x and derivative of cos x means sin x. y2 as sin x, derivative of sin x as cos x. Let us take w1. In w1, just replace this column with 0, 1. In w2, replace this column with 0, 1. w1 indicates Wronskian with respect to y1. w2 indicates Wronskian with respect to y2. Now expand it. So it gives me cos square x minus of minus sin square x. That simply gives me sin square plus cos square, which is equal to 1. For w1, it is 0 minus sin x. w2 is cos x minus 0. So now we have w, w1 and w2. Now the formula for u and v is given by u as w1 by w into sin x dx. Now this sin x is the right-handed function rx. Okay, there is no relation of this sin x with y1 or y2. U is for y1, so I am taking component w1. So it is w1 by w sin x. V is component of y2, so I am taking w2 by w sin x dx. Now, integrating this 2 will give me final answer of u and v. Taking values of u1 is minus sin x, w is 1 into sin x dx. Taking value of v, w2 is cos x, w1 into sin x dx. Let us simplify this. So it gives me minus sin x into sin x, that is minus of sin square x. Using the trigonometric formula of cos 2x, I can convert sin square x into 1 minus cos 2xy. Over here, it is cos into sin. Multiply and divide by 2. So in numerator, you will get 2 cos x sin x, which will eventually convert into sin 2x. So now, we have to integrate these two values. Integrating this with respect to x will give me x minus sin 2x by 2. Over here, it is cos 2x by 2. 2 is already in denominator, so it will give me 4. So, we have final answer of u and v. Taking these values of u and v into our first step of ti will give me final answer of u means minus 1 by 2 in bracket x minus sin 2x by 2 bracket over into cos x minus cos 2x by 4 into sin x. This is nothing but your value of particular integral using method of variation of parameter. Combining it with yc will give me final solution. This is how you can find the general solution of second order differential equation using method of variation of parameter. I hope this technique or this method is clear. In this method, there are no restrictions. As we have seen in case of method of undetermined coefficient, the restriction or the limitation is you cannot apply the method of undetermined coefficient whenever differential bases are infinite. Direct methods, they are itself limited to the 5 cases, whereas the method of variation of parameter is general in that sense. But the problem is you need to know how to find Wronskians and how to integrate the function wi upon w rx dx. If you know all these things very well and if you are good at integration, you can adopt this method as a general method. This method is capable to give answer for any second order differential equation. In my next video, my focus will be on how to solve third order differential equation using method of variation of parameter. Try to observe or try to think that how you can generalize this method to method of third order differential equation. We'll see that with help of Wronskian. At this time, I will suggest you to go through some examples of direct method like exponential, polynomial, trigonometry, or sine cos using this method of variation of parameter. It will be a good practice to solve single question using multiple methods. Thank you.